Hello students, in this video lesson I will be completing exercise 7.3 from triangles and at the end I've given you a couple of revision questions from lines and angles in the form of MCQs and some solving time. Please have a look. This is question number 4 from exercise 7.3. Now this diagram will look very familiar because the same question is given in exercise 7.2 and we have solved that in a different method. Here it is specifically mentioned to prove triangle ABC by using RHS congruence rule. We can prove this triangle as an isosceles triangle by different methods. One is by AAS congruence rule and the other is by RHS congruence rule. Now let me remind you how we had done this by AAS congruence rule. So this was the solution wherein we took triangle AFC and triangle AEB. And in this, AEB is congruent to AFC because it is given, each is 90. A is a common angle because it is an angle common to both the triangles. And this altitude is also congruent, it is given. So if you look at it, it becomes angle, angle, and one side. So which is the side that is congruent? This is the side that is congruent to this side. So by AAS congruence rule, we can prove this triangle as an isosceles triangle. Okay. But here they have now asked us to prove it congruent by RHS congruence rule. So let us see how to prove it congruent by RHS congruence rule. Have a look. Now the same diagram, question is the same. Exercise 7.3, question number 4. I want you to write down this in your book. Now, to prove it congruent by RHS rule, we will take a different triangle in this. We will take triangle BCF and triangle CBE. Now, if you look at these two triangles, F and E, both of them are 90 degree. So obviously BC becomes the hypotenuse because it is the side opposite to the right angle. And you notice that this hypotenuse BC is common to both the triangles. So this is the solution. The two angles are equal because each is 90. Then hypotenuse BC is congruent to hypotenuse CB. It is a common side. And we know that this segment FC is congruent to this segment EB, or you could say side FC congruent to side EB. It is mentioned that the altitudes are equal. Therefore, the two triangles, they become congruent by RHS congruence rule. By now, you would be aware of the criteria for this rule. It is the hypotenuse should be congruent. Obviously, the triangle should be a right angle triangle and one of the perpendicular side should be congruent. So in this, BE is one of the perpendicular side and CF is the other perpendicular side. Therefore, the two triangles are congruent by RHS congruence rule. Now, in order to prove that triangle ABC is an isosceles triangle, we need one CPCT. So, the CPCT that we get out here is B is congruent to C. That is angle FBC will be congruent to angle ECB, right? So, because of CPCT, angle B is congruent to C. And you know that in triangle ABC, if here B is congruent to C, then AC becomes congruent to AB because they're the sides opposite to equal angles. And if two sides are equal, the triangle becomes an isosceles triangle. So students, this was exercise 7.3, question number 4. We have done this by RHS congruence rule because they've asked us to prove it by RHS congruence rule. And in the earlier slide, you saw the same question, but we had proved it long back by AAS congruence rule. And if nothing is mentioned, the choice is yours. You could prove it by any congruence rule. Okay. Now this is question number 5 from exercise 7.3. It is given that ABC is an isosceles triangle and AB is congruent to AC. The indication is put here with a red marking. Draw AP perpendicular to BC. So I have drawn AP perpendicular to BC. Here I've indicated it is a right angle, and you have to show B is congruent to C. So this is also fairly simple. You will take the two triangles, that is triangle APB and triangle APC. Now, how do you prove them congruent? By which rule? You will prove them congruent by RHS congruence rule. And how so? The hypotenuse is congruent, right? And what is the criteria I said? That one of the perpendicular sides should be congruent. So isn't AP the other perpendicular side? See, there are two perpendicular sides to this triangle. One perpendicular side is AP, the other perpendicular side is BP. Again, for this triangle, one of the perpendicular side is AP and the other perpendicular side is PC. So you notice that the hypotenuse is congruent. So I've written hypo AB congruent to hypo AC, right? And the two triangles are congruent by RHS congruence rule. And if they are congruent by RHS congruence rule, then this angle B will be congruent to angle C, right? And if B is congruent to C, that is what they have asked. We have hence proved it. Okay. So students, with this, I have completed exercise 7.3. Now let us look at some revision questions from lines and angles. So completed all the three exercises. Exercise 7.4 and 7.5 is not there. It is deleted. Now your portion for the second periodic exam. You will have lines and angles, the full chapter. A part of it was taken in the semester exam. And surface area and volume, you will have that only up to a particular exercise, that is up to 13.4. Okay. Now let us look at questions from lines and angles. Some are in the form of MCQ and few questions are in the form of solving time. Have a look. Students, these are some of the revision questions in the form of MCQs from lines and angles. I want you to solve them. Okay. A couple of MCQs are given. Make a note of this in your geometry notebook. And maybe in the next video lesson, I will be giving you the answers to these. Okay. If one of the angle of a triangle is equal to the sum of the other two angles, then what kind of triangle it is? Do it on your own. This question is also pretty much easy. Okay. Have a look at few more questions from lines and angles. This is a diagram based question. If you remember, such type of questions we had given in the first periodic exam. They're angles in a linear pair, so they will sum up to 180 degree. Angles of a triangle and the ratio 3:5:7. So when it is 3:5:7, you write let the common multiple be x, get the value of x, and find out what type of triangle it is, because you will get the three angles. And based on those three angles, you will know what type of triangle it is. Now, these are solving type of questions. These questions are very similar to what is given in the textbook. Only thing, I have changed the number out here. I've changed the values. Okay. So this is easy. You know what alternate angles are. Accordingly, you can find the value of y. Similarly, you can find the value of x because they are angles in a linear pair. There are different ways of solving this. So please find the value of x, y, and z. Here the two lines are parallel, so they become corresponding angles, and you have learned that corresponding angles are equal. So equate them, 3x plus 5 equal to 4x. From that you get the value of x. So these are also solving type questions. The diagrams may look very familiar because same diagrams are there in the textbook from the exercises, but only thing is the values have been changed here. So please do these solving type questions in your geometry notebook. Now, I want you to practice exercise 6.2 and 6.3 thoroughly. 6.1 exercise is also there for your second periodic exam. Then you practice the proof of the angle sum property of a triangle. There are various theorems and many proofs are there in this chapter. Now from theorem, you just learn angle sum property of a triangle. Okay. Then I would be continuing with revision questions from lines and angles until your second periodic exam. Okay. So students, we end this video lesson out here. Look for revision questions from lines and angles in your forthcoming video lessons. Thank you.